It is recording.
Live at the palace.
Live at the palace. All right. So we're going to look at last night's homework, which tonight I'm going to give you a lot of practice, and we're going to do some of it in class today on evaluating these trig functions so that there's no confusion, because some of you were a little bit confused last night, and some of you don't understand reference angle. I thought you understood it from pre-calc, but apparently you don't. And I had a lot of people come in with questions about the reference angle. And so when we look at this, it says use the given point on the terminal side of angle theta to find the value of the trigonometric function indicated. So number 77, we want to calculate secant of theta. So theta is this angle in red. Angle in red. All right, it's the angle in red. It's not, now every angle has a reference angle. Okay, what is a reference angle defined as? Yeah, it's the distance from the terminal side of an angle to the x-axis, always to the x-axis. So the reference angle here would be this little guy right here. Okay, that is the reference angle. Okay, so every angle has a reference angle which forms a reference triangle. A triangle can only be formed with angles that are less than 180 degrees. So if you have angles that are bigger than 180 degrees, like we do in red here, which happens to be a negative angle because we're going clockwise, does everybody agree with that? One breath. Okay? So this angle, all the way in red, is a negative angle. It doesn't have a triangle because it's bigger than 180. So you can't even construct a triangle off that. You have to use its reference angle. Now here's the thing that we learn about angles, is because this reference angle and this angle terminate in the same spot, they're basically coterminal. And if they're coterminal, every coterminal angle is going to have the same reference triangle. This is not real difficult. All you got to do is construct a triangle. And what I'm trying to get you guys to think about is that when you look at the triangle, I don't want you to think of it as just opposite, hypotenuse, and adjacent anymore. I want you to think of it as x, y, and r. The horizontal distance is always x. The vertical distance is always y, and the hypotenuse is always r. That's the way we think of it in this class. That's the way you need to think of it in calc. You can't just think of it as opposite over hypotenuse anymore, and adjacent over hypotenuse, and opposite over adjacent, and yada, yada, yada. You need to think of it in terms of x, y, and r. So the horizontal side is x, the vertical side is y, and this is r. Now, did they say we're in the unit circle? Does this specify anywhere that we're in the unit circle?
No.
Now, everything is proportional to the unit circle, but if they don't specify that this is a value in the unit circle, then you can't assume r is 1. It might be one of those other concentric circles. Okay? I don't know what the value of the radius is. It could be the unit circle, but this point might not be on the unit circle. You can't assume that that point is on the unit circle with the radius of 1. Might be, but it's not guaranteed. We have to find out if it's actually the unit circle we're going to be looking at if I was to draw a circle through that point right there. Okay, maybe it is, maybe it isn't. I don't know. Okay, we're going to find that out. That's what we're going to do right now. So what you need to know is that all of these angles, and there could be other angles. I mean, you don't have to do that one. We could do another one here. I'll do one in black. Maybe it's this angle. That right there is coterminal with that red angle, which also has the same reference angle. That black angle and that red angle have the same reference angle in blue there. Therefore, they have the same reference triangle. And that's all you need. Now, when you look at sine, cosine, and tangent values, all they are, when you look at them, is just trigonometry was invented, okay, or discovered because somebody noticed that there was a relationship between the angles and the sides of a triangle. Okay, there was this relationship that they discovered between the angle and the sides of the triangle. Before that, all they had was Pythagorean theorem, and all that did was relate the sides. And then for angles, the only way you can relate the angles is just knowing that 180 degrees all three angles added up to 180 degrees. That's how you related all the angles. Trigonometry was invented so that you could relate side measure to angle measure. So sine of the angle theta is related to the opposite and the hypotenuse. It's equivalent to the ratio of the opposite and the hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent is opposite over adjacent, and then the secant, cosecant, cotangent are just the reciprocals of those. That's all a trig ratio is. If I showed you what sine actually did, it'd take me about an hour to do it, and no way you'd understand it. Because to prove what sine, cosine, and tangent actually do, their actual numeric operation, is about 3-page proof, and it takes count 3 to do it. All right, so if you go that far, you actually get to see how they calculate sine, how your calculator actually calculates the sine value, how your calculator actually calculates the cosine value, because you don't know. Ain't nobody's ever known in here. All right, same thing with log. How do you figure out a log? You get your calculator out, let your calculator do it, because you don't know how to do it without a calculator. Same thing with trig values. So when I want to find the secant, the way that I go about this is I'd go ahead and write down what x and y are. X, y, and r. So what is x? Well, x happens to be 2 root 3. It's positive 2 root 3. That matters big time, because that's going to let you know what quadrant it's in. Y is 2, and we don't know r. How can we find r? Pythagorean theorem. So we're just going to take x squared, which is 2 root 3, squared, plus y squared, which is 2, and it's equal to r squared. And I know I did this one yesterday, but I'm doing it again because some of you just didn't get it the first time. So we need to make sure we got this. Okay? When you square a root, you got to square, when you square the 2 root 3, you got to square everything. So you square the 2, what do you get? 4. When you square the root 3, you get what? 3 plus 4 equals r squared. So we're going to have 12 plus 4 equals r squared. So what does r equal? 16. You get r squared is equal to 16, so therefore r is equal to 4. Now we know r. I can find any 6 of the trig ratios that I want if I know x, y, and r. Actually, you can find 2 of them without r. You can find tangent and cotangent without r, because tangent's y over x and cotangent's x over y. Okay? I would memorize. Make sure you got it memorized by tomorrow. Sine is y over r, cosine's x over r, tangent's y over x. Cosecant's r over y, secant's r over x, and cotangent is x over y. X over y. You need to have all 6 of those memorized by tomorrow. Hint, hint. Make sure you memorize those 6 trig definitions. You should already have them. And if you forget them, it's easy to remember. You just construct a little right triangle with x, y, and r and just say, oh yeah, I forgot. What is sine? Well, there's theta. It's opposite over hypotenuse, y over r. What's cosine? Adjacent over hypotenuse, x over r. What's tangent? Opposite over adjacent, y over x. Okay? Now I can find all 6 trig ratios. If I want, I only need 1, but I'll show you a couple of them. If I wanted to find sine, sine of theta is y over r. Well, what's y here? 2. What's r? 4. So what's sine of theta? Sine of theta is equal to 1/2. Pretty simple. How would I find cosecant? Well, cosecant theta is the reciprocal. It's r over y. Well, since the answer is 1/2, instead of doing the work again, let me just flip 1/2. What's 1/2 when you flip it? 2. There you go. So we got cosine, we got sine and cosine, cosecant. You could go through and do secant and cosine now. Okay? Cosine. Cosine of theta. By the way, I realize that this is unit circle values, and I'll tell you why I know that now. Okay, cosine. X over r. So it's going to be 2 root 3 over r, which is 4. That reduces to root 3 over 2. Okay, so there's cosine. I actually know this angle. Does anybody know what it is? What angle is this on the units? Has to be 30. Has to. Okay, because in the unit circle that you just did for a quiz yesterday, you got cosine's root 3 over 2, and sine is 1/2 at 30. This is actually the unit circle. Some of you are like, no, it's not. The radius is not equal to 1. Everything is proportional down to the unit circle. If I reduce all these, look at this. What does it multiply by? Looks like by a factor of 2. Kind of. Yeah, more like a factor of 4. Okay, what is secant? What is secant? Reciprocal. So if I do the reciprocal, let's reciprocate this one, because that's pretty easy to reciprocate. It's 2 over root 3. What does it end up being?
2 root 3 over 3.
2 root 3 over 3. That totally makes sense to me. There's our secant value. By the way, somebody probably saying, what do you mean it's a to reduce this down to a unit circle, you have to reduce the radius down to what? 1. Divide all these by 4 and see what you get. What do you get when you divide that one by 4? Weird. What do you get when you divide that one by 4? Weird. What do you get with that one? Look at the unit circle and see at 30 degrees if it's not root 3 over 2 and 1/2 with a radius of 1.
Wow.
So there's your proof that it always reduces down to the unit circle. Pretty cool. You could do tangent and cotangent if you wanted. What would tangent look like? It'd be 2 over 2 root 3. Which would be 1 over root 3. Which would be what? So 3 over 3. What about cotangent? What would cotangent be? I'm going to cheat a little bit here. I'm going to flip this one right here.
2 root 3.
Oh, no, I'm going to flip this one right here.
So root
You can
3.
flip any one of these, but I'm going to flip this one. Looks like the easiest. What is it
Root
going to be?
3.
There you go. Now, we know what the angle is because of the unit circle. Let's say you didn't know what the angle is. Let's say you just didn't know. You're just like, I don't even have a clue what the angle is. How could you find the angle with your calculator? You could take any one of these. Let's just do it. Take your calculator out, and I'll prove it to you. Any 6 of these. Any one of the 6. You can take any one of the 6. I'm going to tell you, I don't really mess with cosecant, secant, and cotangent on the calculator because it's so messy to do. Sine, cosine, and tangent, though, are easy to do. You got the buttons right there, right? You could do any one of the 6, and I bet you, if our calculator is in degrees, we're going to get 30. Let's try the sine one first. Sine of theta equals 1/2. How would you find the angle if sine of theta equals 1/2? How would you find the angle if sine of theta equals 1/2?
Inverse sine.
Inverse sine of 1/2. Try it. Do second sine of 1/2.
30.
Oh my gosh, 30. Let's do the other one. Let's do cosine. Cosine theta equals what? Root 3 over 2. Do inverse cosine of root 3 over 2. Just
30.
do 30. Somebody help those people. Okay? Tangent. Do tangent. Okay? Tangent is supposed to be equal to root 3 over 3, right? So do inverse tangent of root 3 over 3. Got it now, Ben? Got it now, Peyton? Do inverse tangent of root 3 over 3. Okay, 30. Got to help each other in here. I'm not going to hold your hand. We're going to take the passy out of your mouse. Man up a little, and woman up. Okay? All right, makes sense? Is that good? Okay? Any questions there? Does that make sense what you were to do now with this part of the assignment? Okay? I'm going to give you so much homework on it tonight, you're going to get sick of it. I'm going to have you swimming in trig ratios tonight. Sorry, that's just the way it is. It's an Aspen. All right, I want to stop this recording. I'm not going to record this whole time. Sorry, Jackie.